this computer. All right, so now we're recording. All right, so what we're going to do first is to take a look at the R website. Okay. All right, so R is, like I said, this sort of open source programming environment effectively that's fundamentally designed for statistical work. It has been designed by committee. So that's good and that's bad. It means that there are all sorts of functions and many pieces of programs effectively that people have created that operate in the R environment. Because if somebody has a problem and they're a decent programmer, or if they know someone who can do some programming, they'll write a function to solve the problem that they're having. I have to do this, I have to do this, people do it. So there's all sorts of functionality, like much more functionality than any single probably statistical software package that's out there. The disadvantage is that since each of these things have effectively been written by individuals or groups of individuals, they're not necessarily consistent. So one of the things, if you're familiar with any sort of programming or even spoken languages, you have to worry about grammar. If you want to know, like, what's the order, does the adjective come before the noun like it does in English, or does it come after the noun like it does in Romance languages? How do we talk about subject-verb agreement, things like that? In programming languages, we want to know, what are the rules for naming variables? When do we use a quote? When do we use a single quote? Do things have to be in parentheses, commas, semicolons, whatever it happens to be? One of the problems that you'll see with R is that sometimes the syntax of commands is not consistent. So you have one command that does something and use double quotes around a file name, and then you'll have another command that wants single quotes around a file name. So stuff like that can get really frustrating with it. The good news is there is a huge cloud or cloud-based help system out there, because again, so many people use this all over the place to do so many things. People have run into these problems and they've documented it and explained how to do it. So the best thing about R is that it's free. So free is good, right? Free is good. And free is good from this perspective because it means that you'll always be able to access it. We could teach this class using, SAS or eViews or Stata. But that means that, the cheapest eViews or Stata implementation is probably $500 or $600 on your desktop. A SAS implementation is thousands of dollars. In an organization, it's tens of thousands of dollars. And if you end up, getting a job doing consulting work or for a small company, and you just realize, hey, here's something that I can do, and you don't have that software, then you'll be out of luck. So this way, using Excel and R, I know these are things that you'll always be able to find. Okay, hold on, Tanzer had chatted something. At least it flashes when he chats, even though I'm sharing, so that's good. There we go. We're going to use SQL. He asked if we're going to use SQL. Possibly. There are places in the course where it can become useful. Whether or not we get into it heavily is going to depend probably more on the projects that you all choose. Some people's projects may lend themselves more towards using that query language. Some may not. So as we get later in the semester, there's a core functionality of stuff that we're going to teach. As we get later in the term, sometimes the stuff we do will be based on, so-and-so needs this for their project, so we're going to spend time talking about this particular task. So we will pick and choose where we go at the end based on what you need. So, okay, good question. All right, so to download R, you guys said you tried this and had some issues with it, so you can tell me where you had issues. If you go to the R website like this, there is a link here that says to download R. Do this. If you just follow that link, it gives you this really scary list of things, right? You're like, what on earth is all this? These are just all the servers around the world that are mirroring the real place where the programming language software, the operating system software is housed. Technically, so you pick one of these effectively to communicate with, and that's where it's going to download from. It honestly doesn't really matter which one you pick. For efficiency's sake, you should probably want to pick one relatively close to where you are, because presumably that download should be faster than one that's further away from you. So if we look at the United States down here,
Yeah, there's like a couple in Pittsburgh.
yeah. Oh, yeah. Wow. Yeah. Actually, Carnegie Mellon. Carnegie Mellon actually has one. So there you go. You can pick the one at Carnegie Mellon. There's some in Ohio. It doesn't. Again, it doesn't really matter which one you pick. So let's go ahead. If I click on the CMU one, that takes me to this point. This is just where you need to go. Now you just need to pick your operating system. So R works in the Windows operating system. It works in the Mac OS operating system, and it works on Linux. So you would want to pick the appropriate one for your machine. Presumably, most of you are working in Mac or Windows. I'm a Mac user, so I got that one there. So when you get over here, it's going to give you a little more information about that. Oh, that's just telling me about it. I think I clicked the wrong thing there. Hold on.
I clicked the Windows one and it says right at the top, download R for Windows.
Oh, I think I maybe just missed that.
Or like install R for the first time.
Oh, yes. There we go. No, that's not what I wanted to do. Okay, now this is confusing me.
Did you see his question?
I did not.
He's asking if R was installed in the library computers already.
That's a good question. I know that it is installed in some of the lab computers. I don't know about the library lab. I will check on that. And that's weird because he didn't flash that he had a question. I know that most of the classroom computer labs, like for example in Eberly, have R on it. And I know the other ones we've used, like the Keystone 400 classroom lab has R on it. I will check about that with the library computers and get it installed if it's not. It's a very good question, actually. So anyways, I don't know, maybe it's because I already have it installed on my computer that it's not giving me the link to install it, because it should go here and there should just be a like, oh, install R. The Windows one, it's kind of like, yeah, so that's what it should say.
Yeah, the Windows is like install, and then you click on that, and then it just says download it.
Yeah, and that's pretty much what should be here too. So I'm wondering if it just kind of recognizes that I have it here, and therefore it doesn't want
maybe
to do it. And I don't want to take the time to uninstall it and try and reinstall it, because I'm guessing that's what the problem is. But in any case, this is where you go. Once you try and download it, then it should work relatively easily. And it'll just be in your programs in Windows or in your applications in on Mac. While we're here, the other thing we're going to use is this thing called RStudio. RStudio, I can't say that it makes R user-friendly, but it makes it slightly more user-friendly, because the R operating environment effectively is like a command prompt where I type a piece of code, and then it does it, and it gives me the result. And then it gives me a command prompt, and I type another piece of code, and it gives me the result. And I can go through line by line and do that. RStudio gives me a place where I can write lots of lines of code together and run them as a group. It also gives me some point-and-click capabilities, like I can have a file tree and I can click on a file and tell it to, upload that one. I can look at the data set in like a spreadsheet-like format in RStudio. So RStudio makes R a little more user-friendly. And it's also good because, again, instead of working line by line, you can work on like big chunks of code that you can edit in like a text editor. And then if you find a bug in your code, you can don't have to start over at the beginning. You can just edit it there and fix it up. So RStudio is kind of the other piece that I think is relatively useful. So again, it's just I think it's just rstudio.com. Yeah, it's just rstudio.com. And again, if you do rstudio.com and click on the somewhere there, download RStudio, then it'll give you that. You have to, again, pick the right version that you want. There's a free one. That's the one you want. Pick the free one, and then you can go ahead and download it, and it'll recognize what operating system you're working on. Again, it works on all the same operating systems. But to get RStudio to work, you do actually have to have R on your computer, because RStudio just interfaces with R on your computer. It doesn't actually have the programming language in it itself, so it just is an interface. Okay.
Does it matter if we do the desktop or the server one since they're both free?
It does not really matter. I have actually used both, and they work pretty well. Yeah, I've not really had an issue with either one. Yeah, I was going to say, I don't think I've not found any particular advantage. I think any of the machines, and since you asked about the library before, any of the library machines that have R installed, I'm pretty sure lab machines that have R installed also have RStudio installed. Okay. Because I know when we've used it before in any lab, they always give us both. But if it would not, this is one place, if you're on a computer where you don't have, R is, if you would be in the library, for example, and R is on the computer, but RStudio is not, and you want to use RStudio, the server version should work on those machines because it's not downloading something, it's not using it locally. So I think it should work there. Okay. Does that make sense?
Yeah.
Okay.
See, I'm coming into this class with minimal knowledge on any type of coding. I can work in Excel briefly enough to get the job done, but past that.
And we are going to minimize coding like nobody's business. When we get to the point of using R to do something, I'm pretty much going to give you a set of code. We'll talk about exactly what it does. And then you can cut and paste it into RStudio and run it, and it'll work. And then we'll talk about okay, so what do I have to change, right? If I want to modify it to do something else, you can effectively change that. Just change the variable names, change the formatting a little bit. We're going to do very, very little coding in this class. And it's all going to really be based on models that you're given, modifying those slightly.
So,
make sense?
Yeah.
Yeah. Okay. Yeah. Don't worry too much about the coding piece. It's really just so that you have another option of a place to go to do some of the stuff. And then, like I said, at the end of the term, when we get to slightly more sophisticated stuff that Excel can't do, particularly if your project involves one of those things that Excel can't do, then it gives you a place to go. The biggest limits of using Excel for statistical work, particularly regression, we're going to do, is there's a big limit on how many independent variables you can use. Because Excel works in a fixed matrix size, right? I mean, while that spreadsheet seems like it's gigantic, you can go and go and go forever in either direction, it actually does have a limit to how big it is. And because of that, there's a limit to how much what sort of calculations it can do in the background, because it has to fit everything that it's doing into that spreadsheet size that it has. And because of that, they limit the number of variables that you can use. And it's actually pretty easy to get to a regression that uses more variables than Excel can use. So that's the main reason you need another option. Good?
Yes.
Okay. So effectively, like I said, I can talk a bit about, in general, what the class is about if you want, and I'll answer other questions that you have. If you want to talk about possible term paper projects at this point, happy to do that, or happy to put that off to the discussion board, whatever works for you. Econometrics is, to me, a really fun class. I'll be honest that this was the class that convinced me to become an economist. I don't know if that's like a plus or a minus in terms of like convincing you that this is a fun class, or actually I'll stop sharing so you can see me while I'm talking. So I don't think we need that. There we go. This is kind of the class that convinced me that I wanted to be an economist. I was an economics major, but I really thought I was just going to go find a job after undergrad or maybe get an MBA or something like that. Took this class and got excited about solving problems on my own using data, using the tools from this class. Effectively, if you're the person that, like, when you took any other economics class, you wondered where the graphs come from, like, how do I know that that's what a demand curve looks like? How do I know that's what a utility function looks like? How do I know that that's the relationship between gross domestic product and consumption? How do I know that there's a relationship between interest rates and unemployment rates, things like that. So if you ask those questions about, like, why are you drawing those graphs and how do you know where they came from? Econometrics is the class where we can take what data we have from the real world and estimate what the functions underlying it look like. So if I have a bunch of data points, what this class is really about is it's about picking the line that fits the data best, right? It's about it's about estimating the underlying relationship, the thing that we would draw in micro or macro or health or whatever. It's about how do we know what the line looks like. That's interesting because we want to model them. So there's three uses of econometrics that you learned about if you read chapter 1 so far. It's interesting if we want to model it, just because I'm interested in, like, what does the relationship look like? I want to, like, actually figure out that the demand curve is downward sloping, and maybe that the slope is equal to -1, or that the price elasticity of demand is -0.5, whatever it happens to be. So if I want to build a model of the relationship, that's good and that's useful. More often, and what we focus on in this class, is testing relationships about the data. So we want to ask questions about, like, is demand for this product price elastic or price inelastic? Is there a positive or negative relationship between income and demand for this product? Is it a normal or inferior good? Is there any relationship, any statistically significant relationship between one variable and another? So this is where we start asking those questions and trying to answer those questions. So what you studied in business statistics, for example, is descriptive statistics, where you were trying to create numbers that summarize a data set or tell me something about a data set. In this class, we use statistics to answer questions. That's a whole nother branch of statistics. It's called inferential statistics. This is where we're trying to draw an inference. Remember, the word inference, like, comes from infer. So it's where I try to draw conclusions or make decisions based on the relationships I see with data. So anytime you have these sort of questions and there's data related to it, and I want to say not just, like, looking at a picture, not just looking at descriptive statistics, but instead, like, trying to draw real concrete evidence-based inferences from that data, this is the stuff we do. So we can model data using econometrics. We can test hypotheses, answer questions using data using econometrics. And then the last use is forecasting. We won't touch a lot on forecasting in this class because, again, the focus is the research piece of it and answering questions. But any of the relationships we just talked about, you could also then predict what would happen. If it's a time series relationship, we can predict what happens in the future. If it's a not time series relationship, we could predict what would happen if we had an example that was different. I was just actually, before I got in here, talking to a real estate agent. And in real estate, for example, what we're interested in is, like, how do you know what a house is worth? This is important if you're like buying or selling. It's also important in public economics. If you took Dr. Mateki's public economics, you talked about property taxes at some point. Important thing in property taxes is how we assess homes, right? How we determine what their assessed value is. That's an econometrics project, right? That's an econometric question, because I need to know, without knowing what a particular house has bought or sold for, I need to know what the characteristics of a house are worth. Right. So I have tons of data on house sales, but I don't have any data on the particular house I'm looking at. So how do I know that this house that was built in a particular year, that's in a particular neighborhood with a particular number of square feet, bedrooms, characteristics, whatever, how do I know what all of those things are worth so that I can guess at, I can predict, forecast the value of that particular property? That's another type of econometric problem. There's lots of cool things. There are lots of cool projects that you can do along that line. So that's another interesting thing. Tanzer's typed a very long question here. So I'm going to read the question. That's a very good structural question about the class. So effectively, I don't know if it records the question, so I'm going to read the question just so that anyone watching the recording knows. So it's an all-encompassing question. How would you recommend we go about managing our time when it comes to the quizzes and readings versus doing the project? Should we focus more on the reading material and trying to conceptualize it? Or should we hit the ground running and start the project and just start doing the material? Reason I ask is because when I looked at the requirements for the project at first glance, it was rather daunting. The project is definitely rather daunting. I will totally agree with you on that. But we intentionally break it down into small pieces that guide you through the project, hopefully leading to success. I know a surefire recipe for disaster in this course would be, say, okay, here at the end of the semester, you have to give me this term paper that, uses regression analysis to answer some research question, has a literature review and all this stuff. And what I would get, most people wouldn't even turn it in because it would just be such a disaster, right? So literally we've broken it down into a bunch of little chunks. The chunks are very manageable. And the good thing about them is after each and every one of those, you're going to get a lot of feedback and direction. This is not a project that you're going to be out there on and I'm going to leave you on your own to do. I'm going to bother you about it constantly. I mentioned already, I think if you watched the video about the project, once we turn in the proposals, I'm going to mandate that we all have one-on-one meetings to talk about the project. Okay. And if you're on campus and want to come to my office, feel free to do that. Or if you want to do it like this, that's fine too. I don't really care how we do it. But we have to have a one-on-one meeting about the project. And that's where we're going to devise a plan to work on it moving forward and making sure that you're successful. Now, in terms of where you balance the week-to-week work versus the project, they do go hand in hand. And I've tried to balance when the project turn-in pieces are due with where your knowledge is coming of the econometric techniques. Because right now, and this is why, Emily, I know you said in your post that you're just I don't know where to even start. And I get that because you don't even know what the discipline's about. You don't even know what econometrics is. And yet we have to try and come up with a term project topic. So that is challenging. And this is the sort of hardest piece because, within a couple of weeks, you have a much firmer understanding of what that is and what it looks like. And we're going to spend time, once you have a project topic, we're going to spend time looking at what other people have done related to it. And that's going to give us one time in the class to build more econometric knowledge, more technique knowledge, while you do the literature research. That literature research is also going to really help you figure out what your project should look like. Because no research happens in a vacuum. You shouldn't try and reinvent the wheel every single time. You have an idea of topic, a broad topic. You come up with a question related to that topic, and then you see what other people have done so far. There's no rule in this class that you can't just replicate what someone else has done. No one said that this had to be novel publishable research at the end of the day. I've had lots of students who do write stuff that gets published out of this class, but it doesn't have to be. You can find a great project out there and just replicate it, maybe with a different data set or even just with the exact same data set that was used. That's a perfectly acceptable way to go forward. But we want to make sure that as we work on our project, we rely on what other people have done in terms of like, where's the right data, how do I build what's the right model look like, what variables belong in the model, all those sorts of things. These are questions that other people have already answered, so we're going to get there. But back to Tanzer's question, it's kind of a simultaneous thing. I've tried to balance when stuff is due so that there's not like a bunch of major stuff due at the same time. So like, this first couple of weeks, there's just like quizzes, and I want you really thinking about the project topic and writing that proposal. There's no like, we're hardly touching a computer to do any regressions or anything like that, or start playing with it until after that's done. Then we have a lab after that where we actually start doing some stuff. That's the next thing it's due. Then we get to the next piece of the term project that's due. So I kind of try and balance it back and forth, so that you don't have, I think there's 1 week where you're working on both a lab and some piece of the project at the same time. But I think it's like around Thanksgiving where I gave you an extra week to do everything anyways. So I was really tried to be really mindful about the due dates of everything in the schedule. So I don't know if that was a long answer for your long question. I'm not sure if it really helped or not, but so effectively, again, what the what econometrics is about modeling relationships, causal relationships. So again, this is when you think about a term project topic, you really want to focus on that causal relationship idea. So I want to be able to point to something that as it changes, it causes something else to change. And these don't fixate on this has to be some grand like economic theory thing. Yes, this is an economics course, and if you want to write a paper about the Phillips curve relationship or about the marginal propensity to consume in less developed countries or something like that, great. By all means, go and do it. But the social sciences broadly are full of causal relationships, and any of those are fine. We don't have to this doesn't have to be some fancy economics-oriented thing. It can be any sort of decision, any sort of situation in which we have data that describes a set of X variables, set of independent variables that as they change, some Y variables affected. Okay. I'd probably avoid the hard sciences. I don't think any of you really want to go and talk about how, atmospheric pressure affects like hurricane formation or something like that. But the same techniques can be used with that data, not social science data. Thinking you all want to stick to probably social science data. So economics, marketing, just broad discussions of these sorts of things. So do those things sort of help?
Yeah, for sure.
Okay. The keys with the project, and at this point, think about a topic. Emily, you had suggested a couple areas that you were interested in. Unfortunately, I had that open and I closed it. So you had talked about some ideas you were interested in. So and the last one in particular it struck me. I mean, this is a classic sort of social science type question. Your last one that you mentioned was, sort of how the millennial generation, say, has a later time when they start families, there's a later rate, or there's a lower rate of actually people having children in that generation, and asking questions about why that is. That's a classic question in the social sciences. I mean, it's kind of economics, it's kind of sociology, it's kind of anthropology, but this is definitely the type of topic that one could address with, the statistical tools we're going to talk about here. The thing that you want to do, if that's a direction you want to go, is you need to start going from those broad generalist type of questions and topics to something much more specific. The more specific we can get with the research question, the easier it is to plan out the project. So if you looked at that discussion of what is a broad question and what is a vague question, the broad questions are the ones that just cover so much ground. It's not really clear even what you're trying to talk about. So I don't know. I'm trying to think of another broad area. Nadine, is there some broad topic area you're interested in?
Well, I'm on the page. It says, how does tax policy affect economic growth?
Okay. Yeah,
I don't like taxes. I'm not doing anything with taxes, though.
Okay, good. That's a broad one. Well, so you guys are all in Dr. Mateki's health econ class, probably, right?
Yeah, I took it last semester.
Yeah.
Okay. That was last semester. That's right. What's he teaching this semester?
Actually, I think I took it last fall.
Oh,
Yeah.
okay. Yeah, it's in the fall. I was going to say it's in the fall. I thought it was the fall that he taught that. So I mean, I think I wrote public econ question or examples in there, but so we think about health economics or healthcare broadly. We could think about there's this general feeling that having health insurance is good, right? So a ridiculously broad, vague question, is having health insurance good? Because I don't even know what that means, right? Like I don't even know what the health insurance side of that means, quite honestly, because that can mean a lot of different things. And I certainly don't know what it means by is good, right? So when we think about a really broad, if we think about a really broad question like that, it encompasses too many things to even start to answer, right? But that's fine. That's a topic area that we can then narrow down into something that's more specific. So, like, I don't know, what is something that is maybe good about health insurance? Those of you who took health economics maybe know some of these things.
Not much.
Yeah. Okay, not much.
Well, I mean, it helps you if you're sick. If you get in an accident and you don't know what's like a accident you don't have planned and you don't have money, I guess, to pay for it.
That's true. That's very true. So it definitely helps people, it covers uncertainty like all insurance does, right? That's a good thing. What do we know about uncertainty and decision making? If there's a lot of uncertainty, what happens to the quality of your decisions?
I mean, that's not good.
Yeah, they're not as good, right? Because I'm working with less information, right? If I have perfect information, then I should be able to make really good decisions, right? Because if I know exactly what's going to happen and I know exactly what something's worth to me, I know exactly what it's going to cost me, then I should be able to make an optimizing decision. I should make a right decision, right? The problem is when we have uncertainty, we're less likely to make the right decisions. Yes, because it's not that we're being irrational, it's just that we don't know all the information when we make the decision. Okay, so health insurance helps take away some of that uncertainty, right? So health insurance in general should help people make better decisions. Health insurance should make your life less questionable and therefore make better decisions. Okay, one aspect of one thing that may be good about health insurance is that it encourages people to seek preventative care as opposed to waiting until they're really sick, right? So if you know anything about medicine, it's way cheaper to prevent you from getting sick than it is to deal with things once you do get sick. So one of the huge things about health insurance is that we expect that the net cost should be lower because we'll treat people earlier enough. Okay, so is health insurance good? We could say, does health insurance lead people to seek preventative care? Okay, that's better, right? Because now we have a specific thing, we're talking about in terms of a Y variable, the outcome, right? Seek preventative care. We'd still want to define more clearly what we mean by health insurance, right? Because now we want to start talking about how we would operationalize this, right? So we would want to go down to the point where we're able to say, well, does a particular health insurance program, does increasing Medicaid eligibility lead to the Medicaid eligible population seeking more preventative care? Okay, this is something we can now define. We can compare states that did expand Medicaid eligibility to states that didn't expand Medicaid eligibility. So now we have we have an X variable that is our experimental variable, increasing or not Medicaid eligibility. We can look at all sort of other characteristics of the population, and then does that increase preventative care, people seeking preventative care. To make this final, like we'd probably need to define more specifically what that preventative care thing is, right? The rate at which people, have annual physicals, or the rate at which people who have diabetes, like, I don't know, or actually the rate at which people are tested and diagnosed with like a pre-diabetes situation. So this is kind of where we are, right? So you can take whatever it is, start thinking broad, post those ideas, right? So we can start talking about this like big, broad area. I'm really interested in like puppies, or I'm interested in online dating, or I'm interested in like health economics, or I'm interested in urban and public economics, like economic development, local economic development. I'm interested in education, anything like these things. And then we want to focus more and more and more on like, what are some causal relationships? What's something that like is affected by other things? Then define those more clearly. So at the end of the day, we can get to something like, does decreasing the marginal income tax rate lead to faster real growth in real GDP growth? Something like that. Make sense? But you have to start thinking about this. This is one of the situations where you need to start brainstorming, start writing stuff down, and then you're gonna. If you start writing stuff down, then you're really gonna start getting ideas together that make sense. All right. Any other questions?
I have one.
Go ahead.
I guess it's kind of still branching off of the millennial concept. Would a way to narrow it down be comparing college debt between generations and see if that's affecting the start of families or the average age of buying your first home?
Those are really interesting questions. I think that could be a definite direction to go. So I think so I think those are possible ideas as to why. So I think what you want to do with this project, if that's the direction you want to go, is continue thinking about those possible causes, and continue thinking about, well, how would I define the terms and variables that I care about here? And what is it? Is it age at which you start a family, number of children, those sorts of things? How do I define these possible X variables? And then I guess my real question is, in that one's going to come down to what's data look like. But that's a secondary concern. Let's think about getting a good question, and then we'll start thinking about what's feasible in terms of data availability. But I think it's an interesting topic, and I think, again, this is where you want to go. And it's never too early to start doing a little bit of literature research, right? So like if you really have an idea that you think you're really interested in, but you have a hard time narrowing it down or writing a question, then start playing around with the library resources and see where we can go with that. And maybe you'll find somebody did something that said, oh yeah, this is kind of what I was trying to say, that'll take you in a different direction.
Okay.
Good. I'm going to try and create a little video, or have Monica Ron Rogers, our business resource librarian, create a little video about using EconLit, which is a subset of the Business Source Premier database, to help look for these things. So that'll help you with the literature search. And again, it's more aimed at the next two pieces of the project after this, but again, it's never too early to start on this. So. Anything else?
I don't have anything else.
Okay, awesome. Well, I'm gonna